Hi, welcome to another mini lecture on pre-calculus. Today's topic is sketching the graph of y is equal to a sine of bx, or y is equal to a cosine of bx. So you remember that we went through the basic transformations. Transformations, we have two types. We have shifting and we have scaling. Each of them can be in the x direction or y direction. You can understand the transformations by point plotting, or you can understand them in the sense of movements of a graph. Either of them has its own advantages. Let me just quickly refresh your memory. So if we start with some function, let's say sine of x. Then we said y is equal to 2 sine of x. This 2 here is playing the role of this a in that case. What did 2 do to the picture? Made it twice as tall. Okay, so it's a vertical scaling. How about y is equal to sine of 2x? You can read this as twice as fast. You can think about it as the horizontal scaling. You can label this thing as a stretch, like a picture becoming that much taller. You can think about this thing as compression. So these two, one in the x direction, this is therefore in y direction, and this is in x direction. Then we have shifting. Y is equal to sine of x plus 2. This meant up by 2. So this is a vertical shift. Obviously in y direction. How about y is equal to sine of x plus 2? What does this mean? This means, are you ready? You want to guess what's going to happen? You remember this is left by 2. So this is a horizontal shift. So of course this is happening in the x direction. These are the primary movements. 2 shifting, 2 scaling, and each of them either in x or y direction. Then we started combining these things. So last exercise we had one set of combination. Now we have another one. Like I have a outside and a b inside. So it is like having this is like that a outside, and then this one like that b inside. This is a relatively easy problem to do, that both of these things are going to happen, and it doesn't matter which one you do first and which one you do second. So let's just quickly go ahead and look at some example. Like this is saying 5/2 of cosine of 3x. So what do? We start with the graph of cosine to begin with. So this one, our starting point is cosine. So cosine, remember, starts at 1 and it goes through this wave. So here is my cosine. The black one is cosine of x. Now we have to do two things. One is make it 5/2 times as tall. So all the heights are going to multiply by 5/2, which is 2.5 times. So 1 becomes 2.5. Zeros multiply by anything, they're always zeros. Minus 1, you multiply by 5/2, that's minus 2.5. And 1 again is, of course, is uh, 5.5. So our picture now has become like this. What have we accomplished so far? 5/2 of cosine of 3x. Okay, to be actually correct, this is the correct notation. This is a bit of a issue there. You need actually a parenthesis around it to be correct. But anyway, so 5/2 of cosine of 3x. Excuse me. Oh, I made a mistake myself. Let's see. Cosine of x. We haven't done 3x yet. Okay. Part 2. Part 2 is, well, what do we do with this factor of 3? Factor of 3, we said that's a compression factor. Is that right? Everything's going to happen 3 times as fast. So it's like running your movie on speed 3. So instead of waiting all the way up to 2 pi for you to see a full cycle of something, the whole thing's going to happen at 1/3 of that time. So this 0 that happened here, 1/3 of that will be at this location. This minimum, okay, so this is here's the x-intercept. What's our final x-intercept? This one went to here, 1/3 of the old location. How about this? We're talking about minimum point. You see this is 6 blocks away, so 1/3 of that will be 2 blocks away. And then you have this other x-intercept. How many blocks are we from the origin? 9 blocks away. 1/3 of that will be 3 blocks, so it will be here, coincides with this one. 2 pi, that's 12 blocks. 1/3 of that will be 4 blocks. So this point will come here. Okay, so this whole thing was 12 blocks if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks. We have to make it 1/3 of this, which means 4 blocks is going to be here. Now my graph is going to go, it's going to be diving very quickly, come down here, and then come back up here, and then reach that location. Okay, you saw what happened. So stretch vertically by multiplying by 5/2, shrink or compress or squeeze or whatever word you want to use horizontally by a factor of 3. Now when you read Alex, it just explains to you to do the same thing by point tracking. That is, take these 5 points, and track them, see where they go, and well, you see exactly what I did here. Let me also show you another way. We are playing with this app here, so it's a cosine. So this is a graph of cosine. Sorry. So A is that factor up front. You see, 1.5 here. So I want to go to 5.5. Here's 5.5, which means 2.5. Okay. Then we have B. B was 3. Notice what happens. I go to 1.5, 2, 2.5, and 3. You see that it compresses. Like if I go all the way to 5, it compresses a lot more. We are at 3. So this is the graph of the function we are after. So that factor of 3 is how much compression you are going to have. factor of 2.5 is increasing the amplitude. Okay, so again, you go ahead and also learn it by point tracking, by making your tables and following the points and graphing that way. Okay, let's go ahead and do another one. This is minus 5/2 of cosine of 1/2 x. So the number in front has two layers to it. That's same as 5/2 that we had before, but a minus also there. What is minus 2? So we have challenge number 1 that we have minus 5/2. Let's go ahead and quickly graph our parent function, which is the cosine. So then multiply by 5/2. Okay, you can multiply by 5/2, then multiply by minus 1, or just go straight forward and multiply by minus 5/2. So let's use the red color. So this is 1 multiplying by minus 5/2 will be here. 0 is easy, it's always at 0. This was minus 1 multiplied by 5/2 comes to plus 5/2. Then the 0 again is 0, and plus 1 goes to minus 5/2. So the graph of, no, we'll come down from bottom, we come to top, then bend down, and then here's the graph of minus 5/2 cosine of x. Next is to deal with what does 1/2 x gonna do. You remember we said if you have 2x, it would have caused the compression by a factor of 2. If you have 1/2 x, it's like playing your movie on half speed or some kind of a slow motion, so everything's going to take twice as much time to show up. So 0, well, it's just a 0. Next point, next intersection is at this point. Stretching it by factor of 2 is going to come here. This one was 4 blocks away, is going to come to 8 blocks away. This one was 6 blocks away, we have to double that, it's going to come here. This was at location 3 pi half, you double it, it becomes 3 pi. This one we were at 2 pi, if you stretch it, it becomes 4 pi. So we have to make everything to stretch by a factor of 2, and so our picture is going to look like this. So this is a graph of y is equal to minus 5/2, then cosine of 1/2 x. So 5/2 taller, minus causes with flip in x-axis or upside down. And then we have stretch horizontally by a factor of 2. So I explained it from the point of view of transformation of movement of the picture. You read your textbook or listen to Alex's steps, and that tells you how to do point plotting. So Alex is going to insist, okay, let's get this one, this 5 points, and then get our picture. Let's go practice a few more. So minus 3 sine of 3 half x. So let's start with sine, graph of sine. What does sine look like? So this is the graph of sine of x. Okay, easy thing. Easy one is, what is this minus 3 gonna do? So we said scale vertically by minus 3. Scale vertically by minus 3, which means 3 times taller, and there is also a flip. Now, as usual, zeros stay where they are, 3 times as tall, but flipping over, it means our graph is gonna do the following. It's gonna go way down, come back up, go to this point, and come down. So this so far is minus 3 sine of x. Next, more critical issue. What is 3 half gonna do? It's always the inverse of that. All the horizontal points are gonna be scaled by a factor of 2/3. Okay, 2/3. If it was a whole number, would have been easier to talk. If it was 2x, you compress it by a factor of 2. If it was 3x, you compress it by a factor of 3. You are going to compress it by a factor of 3 halves. So compress horizontally by a factor of 3 halves. Meaning what? So if I count how many blocks I have here, so from 0 to pi I have 6 blocks. What is 2/3 of that? 2/3 of that will be 4 blocks. So that is the next crossover is going to happen here. Up to 12 I have up to 2 pi I have 12 blocks. 2/3 of that will be 8 blocks. So I'll be here. So these are my x-intercepts. How about the minima? Where's the minima? Well, this is the minimum. 2/3 of that will be here. Yeah, up to this point we have 6. 2/3 of that will be 6. So our picture is going to go down like this, come up. And now we'll have graph of y is equal to minus 3 sine of 3 half x. So because of the fractions here, you might have a bit of a harder time to follow. So let me just do it by point plotting and tracking as well. So the input is 3 half x. Output is, well, first sine of 3 half x. That's what we get to easily. And then next, what this wants to from us is minus 3 sine of 3 half x. Is that right? So now we say if 3 half x are comfortable angles, 0, pi over 2, pi, 3 pi over 2, 2 pi, calculating the sine of that, we have done it 1,000 times by now, it's these comfortable numbers. If you multiply it by minus 3, well, it's going to be 0 minus 3, 0 plus 3, this is plus 3 and 0. Now, what is uh, important is x itself. If 3 half x are these numbers, what is x? Well, if 3 half x is 0, then x is obviously 0. If 3 half x, if it is pi over 2, well, then x is pi third. I multiply and divide. I get pi third. This has to be pi third. And pi third is, if this is the pi here, pi third is this location, and at pi third we want to be minus 3, and that is what this is at pi third we are at minus 3. That's what we do by point plotting. How about pi? If 3 half x is pi, what is x? X is 2 pi third, double of what we were talking about. So that is this point. So that is the point where we are at 2 pi third and 0. This is 2 pi third, and 0. How about 3 pi half? So if I have 3 half, this is 3 half x becoming 3 pi over 2. 3 pi half x is 3 pi over 2. Well, cancel the 3's, cancel the 2's. Easily you see that x has to be pi. X has to be pi here, and that is exactly what we have at this point. This is the point with coordinates pi and 3. Here's x is pi, y is 3. How about 2 pi? If 3 half x is 2 pi, x is 4 pi third. This is 4 pi third. At 4 pi third, the value of the function is supposed to be 0. That's what this point is. This is 4 pi third and 0. So we did it by transformations. We did it also by tracking points. You pick your favorite. As an engineer or scientist, you want those movements. You want to understand the movements. Okay, let's see one more example. Here we have 3 sine of half of x. Let me see. If you pause this thing and solve it, come back, I'll be very proud of you that you resisted the temptation of listening to an answer. You want to always find it yourself. So you have all the tools needed for doing this. So sine of x, that's our starting point. First, the effect of 3. Well, everything's going to triple. Is that right? 0, if you triple it, is still 0. But 1 or minus 1, when you triple it, well, you have tripled it. So, okay, so this is 3 sine of x. Next, here comes the litmus test. What is 1/2 going to do? Remember, we just did this. What's 1/2 is going to do? It's going to stretch everything by a factor of 2. So, well, stretch horizontally. Stretch horizontally, if you're at x equal to 0, well, you're still at 0. If you're at pi over 2, when you stretch it, if you double it, you come here. If you were at that pi, you'll be at 2 pi. If you were at 3 pi over 2, now you will be at 3 pi. If you were at 2 pi, now you're at 4 pi. Did you follow that? So you go to 2, come to 0, excuse me, let me see, where's my undo button? For some reason, sorry for that. So we are doubling, so I have to double this point. For some reason I looked somewhere else. So this is double of that point. This is still okay. I'm down here, and everywhere else was fine. I missed the very first milepost. So I have to go up here, come down, So this becomes the green one is 3 sine of 1/2 x. So vertically stretch by factor of 3, horizontally, so 1/2 means stretch, because 2 means compression. 1/2 means horizontally stretch by factor of 2. Okay, so so the moral of story was we learned how this factor of a and b change the picture. We learned dynamically how does that happen. You want to play with that app again, perhaps to reinforce your understanding of the topic. Okay, until next time, good luck and God bless.